name is Esteban Maringolo. I work as a VAS consultant and senior software developer at Instantiations. Today I'm going to show you how we implemented seamless OAuth2 and OpenID Connect support in VAST. Now, before we dive into the details, let me give you a quick overview of what we'll be covering in the next 20-25 minutes. We'll start by exploring what OAuth2 actually is. Then I'll show you a live demo using it with GitHub. After that, we'll look at some client code examples. Then we'll move into OpenID Connect with demos using both Google and Microsoft. We also see how this integrates beautifully with Vast async framework and discuss a little bit of JSON Web Tokens and wrap up with some final remarks and questions, of course. So let's start with the fundamentals. In the past, when you wanted an application to access a resource on behalf of the user, the only way to do it was to share the credentials of the user with the application. Of course, this was dangerous because it was prone to man-in-the-middle attacks or compromises of the credentials, etc. OAuth2 allows applications to access protected web services and resources through delegation, which means that users can grant access to resources without ever sharing their passwords or private credentials. You can see here how it could be like the workflow. You first register the application with the authorization provider, and then the owner authenticates against that. Then there's an inter-exchange of tokens. I will talk about that later. And in the end, you access the protected resource. So what exactly is OAuth2? Well, many of us already know this, but it's the industry standard authorization protocol. And notice I'm emphasizing authorization, not authentication. That's a crucial distinction we'll come back to later. It works exclusively over HTTPS for security, and it's really more of a framework with various extensions rather than a single rigid specification. So to actually use OAuth2, let me show you how you will do it. The first thing you have to do in the case of GitHub, I'll show you a live demo of this, is you first register the application in the provider. This is like the GitHub registration page for the application. And this establishes the trust between your application and the OAuth2 provider. And you provide basic information, of course, like the name, the description, picture, etc. Once you complete this registration process, GitHub provides you with two critical pieces of information: a client ID and a client secret. The client ID is public. You can think of it as the application username or what identifies your application to GitHub, while the client secret must be kept absolutely confidential. Think of it as your application password. Never ever expose this client secret in client-side code or public repositories. You can see here the secret is there for this particular application. And along with these credentials, you also need to configure something else that's also critical for security, the callback URL. This is where GitHub will redirect users after they authorize your application. It's a critical security feature because GitHub will only redirect to URLs you pre-registered here. This prevents unauthorized applications from intercepting the authorization code. All right, enough theory. Let's go to the live show, and hopefully this will work as usual. Let me switch back to this. I will just create a new session. This doesn't expire. Okay, I will just have pre-saved here. I already registered my thing. Okay, let's GitHub. I have the client ID and the client secret, of course, and I will authenticate this. This is a seaside example application. Okay. Oh no, sorry. I entered my Google credential. This is it. Okay, now it worked. Okay, okay, it's working. It was going through. Here, I'm authorizing the client application that I registered with GitHub, and I will authorize myself to access it. And once I authorize it, I'm redirected to the source application, which is the CSI application I showed you before. And now I have an access token, and as a sample of this, granting me access to my resources, you can see here in the list, this list, all the resources, all the repositories I have in GitHub. Let me go back to the presentation so you can see what actually happened here. Um, you might be wondering how complex is the code to implement this, and this is where our implementation really shines. Well, the first thing you start with is the grant object, where you configure it with your provider endpoint URLs and your credentials. You can see there's like the authorization URL. This is something you get from the documentation. And then the client secret and the client ID and the client secret, which I'm sharing here because it's bogus, it's not real data. I wouldn't do that otherwise. And then with this, you build the grant itself helps you build the authorization URL with all the required parameters to access the OAuth endpoint. And once that, you redirect the user to this URL and you specify the callback. This is all pseudocode. Some of the methods are real, but this is just for the purpose of example of showing you how this works. And the end result of all of this is that if everything succeeded, you will get an HTTP client configured to work with OAuth. With the access token, it will refresh the tokens for you, will do all that heavy lifting for you, and you will be able to access the protected resources as you would do with a regular HTTP client with all the OAuth happening behind the scenes for you. This is how we did it in Seaside. This is basically we asked Seaside to create an action URL. And then when we redirect the user to that to the authentication provider, you can see there we created the URL. We pass a special parameter in OAuth that's called the state. The state is both a security parameter and a convenience parameter. This is what is it's going to be used if the authentication succeeds. It's going to be echoed back exactly as you pass it to the provider. And here we using a quick kind of a trick, so we pass the continuation URL to the provider. So if it succeeds, it will continue. Here we created this. This is the URL. This is the state. And when the authentication succeeds, what we do is to intercept this initial request, looking for this specific query parameter, which is the state, and then we rebuild the URL and just continue using typical Seaside workflow. But Vast's implementation goes much deeper than just the basics because we support the complete OAuth2 ecosystem. We've implemented the core RFC specification, including all the important grant types, authorization code grant types for web applications, client credentials for machine-to-machine communication, even the deprecated resource owner password grant for backward compatibility. We deliberately don't support the implicit grant because it's being deprecated for security reasons. And beyond the basics, which is like using a string as a single authorization token, we also support modern extensions like PKC, which is public key proof of key code exchange. This is used when you cannot save the credentials in your client applications, like I don't know if you're using a mobile phone or a web application or anywhere where you cannot trust the secret could be leaked. Um, then, of course, JSON Web Tokens, and we follow the OAuth2 for native applications specification. And as we support everything, we are moving forward towards OAuth 2.1 support and compliance. Now, OAuth2 handles authorization, as I stated in the beginning, letting you access resources. But what about authentication? That's where the next piece comes in, OpenID Connect or OIDC. While OAuth2 tells you what you can do, authorization, OpenID Connect tells you who you are, authentication. It's built directly on top of OAuth2 and uses, instead of using just regular strings, it uses JSON Web Tokens to convey identity information. And this is the technology that we all know already that powers all those sign in with Google, sign in with Microsoft, etc. It's essentially a simpler JSON Web Token based alternative to SAML or SAML, which is XML based. And if you ever dealt with it, you might know that it's really complex to work with. The workflow, as I won't do the whole animation here, but this is the workflow. It's really similar to the one that you have with OAuth2 because essentially it uses the same workflow. But you can see in the middle that instead of just getting a regular string as the token, you get a JSON Web Token with all the information. One of the biggest and best features of OpenID Connect is something called discovery, which makes configuration incredibly easy. Every OpenID Connect provider has a well-known URL that serves as a metadata document describing their entire configuration. This means your application can automatically discover endpoint URLs, supported parameters, and even encryption keys needed to verify token signatures because JSON Web Tokens are signed, so cryptographically signed. So no manual configuration needed. You just point to the discovery endpoint and you're ready to go. Let me show you this working with two of the most popular providers we implemented, which is Google and Microsoft. And let me go live to this. I'm going to the Google now. This time. This is not this. I'll clear this. Oh, is it not? Oh, sorry. Okay, good. Well, I have this time selected Google as the provider. Same thing, I will authenticate. This will redirect me to my Google account, which I just recently signed out. I'll type my password. And if I did it correctly, it will, of course, ask for the second factor or not. Oh, no, didn't. Okay, and you can see here, I got the access token. You of course, this is for the purpose of this presentation. I'm not going to add, but you can ask for more scope, which is basically what you want to get when you ask for a token. What we get here is the JSON Web Token details, and here I have just by default what I get is the sub, which is subject, which is the ID of the subject, and the small picture that is what you usually see in Gmail or stuff like that. Let me go back to a live. Okay, don't have it open here. Okay, let me. Oh, okay, hold on. I accidentally closed the example, which is weird. Hold on. This, uh, this one. Let me just this. So amazing. This happens all the time in live demos. So hold on. Oh, this one. This is a CSI application, and this is the application when it doesn't open. Hold on. Oh, hold on. Here it is. Well, getting back to where I was. Here, as you can see, we have two preloaded OpenID Connect providers. What I'm going to do here is select the Microsoft one, and as I'm connected to the internet, what it did behind the scenes was to reach out one of those metadata well-known URLs, and I got back all the details like the authorize and token URLs you can see here, or if you're not, I don't know how to zoom it. Yeah, there. And I will type the client ID, which I will have to copy from another window. Hold on. This is this is OAuth. No, no. Let me see. I'll use the Microsoft here. I will copy the client ID. I will copy the client secret. And one of the things that you can do always with this, of course, it's going to be the same workflow, but I can also, and hopefully this won't break, authenticate using the recently introduced WebView 2 component in VAS where you can embed. Well, it's just authenticated me immediately on that thing. So I'm already logged into Microsoft using the WebView 2 component, which is basically an embedded browser. Although that is kind of discouraged, the recommendation is not to use embedded authentication, but to always use the authentication in the browser. So I can do that, and it will open a browser. And I will put my email. I will just sign in. This will probably prompt me here. Hold on. Mhm. Oh, already authenticated. Okay. So, and you can see here, this is just a basic handler for the authentication we implemented, but the application, this is, I'm talking about the desktop application, already have all the credentials needed here. And if I inspect those credentials, you can see I have, well, the OpenID credentials, the scope of that. And you can see we can also provide the JSON Web Token object as a specific object where you can see, could you read it? Yeah, I guess you could. The recipients, the payload, and all the claims in this dictionary, like expiration, all the data that comes with the OpenID token. Let me get back to the presentation here. Okay. Well, and how we did the same is with OpenID. It's very similar to how we do it with OAuth2. The only difference we have here is that we have this helper start authorization with callback add state helper that does all the heavy lifting for creating the callback and handling everything on the client side. If you look at that, one of the convenience things about this is that um, you shouldn't block the desktop UI. And this is very common when you call another service to block it. So what we did was to use our existing async framework. So when you start the this workflow, what you get as a result is a future. So you can continue with your desktop application until the user finishes the authentication. And the framework, of course, handles all the waiting and callbacks for you automatically. And this is of course important because you cannot freeze the UI while doing this kind of operations. Here's like the piece that I was showing you. And in the end, what you get again is an HTTP client, a special class of HTTP clients with all the details. where you can also have the user information, because in the past with OAuth only you don't get the user information, but with OpenID Connect you get the profile info because you know who you are, you authenticated. And at the heart of OpenID Connect identity mechanism, as I mentioned, is a technology that many of us are familiar with, which is the JSON Web Tokens, and they are the foundation of OpenID Connect. Um, JSON Web Token today is a standardized, web-safe way to transmit trusted information between parties, not just for this use, but for other stuff as well. Our vast client library automatically handles all the verification for you. So it checks the token signatures using RSA 256, validates it came from the expected issuer, verifies, of course, it hasn't expired, and perform several other security checks. We package this as a separate application, so you can use it as a separate library independently of all the OAuth2 and OpenID Connect, just in case you need just a web token support with all the full OAuth flow. This is what I was showing you before, just inspecting one of the JSON web tokens. You can see it's SST, well, that's our typical prefix, and JWT and JWS, which is the signed version of it. So let me wrap this with the key takeaways of this demo. Um, our vast library, this is important, has passed the official OpenID conformance test for the basic relying party profile, which is the most common used. So you can be confident that it's fully compliant with the specification. It supports all the major OAuth2 and OpenID Connect features, works seamlessly with the existing HTTP SST HTTP client, which is, I mean, if you use Fast, you're already familiar with, and includes some convenience methods, in particular for Microsoft and Google, that have some particularities, because specs always say something, but there's always something that doesn't follow 100% the spec, and we have that covered already. We've shown you examples working in both desktop and CSI application with support for external browsers and WebView 2 authenticated too quickly. You couldn't see that much, but it's the way it also works. We have some customers using that, the WebView 2, I mean. Async integration means, of course, you can write responsive applications without wrestling with callbacks. Everything will be handled for you. And this is coming in VAST 15 next year. And if you're currently using VAST 14 and want to try it now, just reach out to us. We have a preview available on request. Which brings me to the end of all this time together. So thank you so much for your attention. I hope this has shown you how straightforward it is to use OAuth2 and OpenID Connect in VAST. And I'm happy to take any questions here.
When describing the application, you had a redirect URL that gets defined, and you had localhost. Can you have multiple addresses so that I can have a development on localhost and a production with a recognized external URL?
Yes, you can have more than one.
You can have more than one.
Yes, but the local host is a special case because you can use it without SSL, of course, because you cannot have.
Yes.
Everything else needs to be secure because it works only over HTTPS. That's it. Thank you.